My name is Roman Pfaff. I graduated here in 1996. It was the early days of the A1200. Had quite a bit of fun while I was here. Probably took place in 40 or 50 experiments. Got to do setup and tear down in 24 hours. Occasionally we'd be doing 24/7 shifts for a few weeks at a time. There were a few cots down in the basement that I hear aren't there anymore, but I spent many nights in those.
So my time at the NSCL was kind of interesting. I was involved with really commissioning the sweeper magnet and the associated charged particle detectors, which are used with the monoarray in now the N2 and N3 vault. I think once or twice I spent roughly 36 hours straight trying to make things work and debug, and I have to say that as an outside user now I don't miss that. The one thing that I do miss is all of the scientific interaction, which is something that's really fun when I come back. I can talk to people about what they're doing and find out what I can do to contribute and what kinds of things I can do to participate.
Experiences here, the experience here that I would say has helped me the most since I graduated was having an experimental background. I realized that there can be a difference between really good models, what you think ahead of time might happen, and good experiments which tell you something about what really happened and their differences. That little bit of skepticism, if you will, a good playback between theory and experiment, a good healthy respect for that has been probably the thing that I've used the most since I left.
It was a great experience to be here. So it's a cool place. So it's a lot of things going on in experiment and theory as well. And it's the best place where you can interact with experimentalists. So it's kind of a unique place where you have a blend of theory and experiment. And theory which you have here is oriented on experiment, just to help experiment to understand what they are doing. My advice, so what is my feeling, so if you're doing nuclear theory, so it's important to be very broad. Not only focus on nuclear physics, you have also to understand what is going in different fields like quantum chemistry or solid state physics and high energy physics, because the tools which you use in nuclear physics have very wide application in all these areas. And if you know your tools, you can use it in all these areas, and it's very important to keep in mind that you can apply it in different fields.
Actually, nuclear physics is something that goes towards the understanding of nuclear forces and important aspects of nature. It's fundamental research. So what we do is mainly fundamental research, and it's extremely important because it basically builds up the basis for future advances even in applied research. If we stop fundamental research, if we stop what we are doing now, then of course there will be no applied research in the future, because we try to understand what are the main forces in nature, what matter is made of, all the world that surrounds us. And so this travel into the microscopic world that we do in nuclear physics is really the basis for any kind of improvement in our ability of understanding better nature and use it at our own advantage.